What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 10, Section 2, Non-Right Triangles, Law of Cosines. Let's do it. If you're looking for a missing side of a triangle, what do you need to know when using the law of cosines? So here's an example of a triangle that's set up to use the law of cosines to solve for this side here, x. This is the one unknown. So we have a side, and then we have an angle in between, and then a side. And when we have that, then we can use the law of cosines, because then it's going to be this unknown value that we don't know, x squared, equal to 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of 32. That's how you'd set it up. That's what you need done. So explain what S represents in Heron's formula. So I actually brought up Heron's formula, a nice little infographic that you can use as well. And here's the S, and it explains exactly what it is in this infographic. It's the perimeter, a plus b plus c divided by 2. So it's basically half of the entire perimeter. That's what S is done. When must you use the law of cosines instead of the Pythagorean theorem? It's basically when you have a non-right triangle, right? A right triangle is the place where a Pythagorean theorem would actually be applied and would work. But when it's a non-right triangle, you can't, then you got to go to law of cosines. So that's basically it, done. So here we got a nice little triangle with everything set up, right? Alpha is 120, B is the side opposite beta, C is the side opposite gamma, and we're going to try and first solve for this missing side. So to do that, we're going to use the law of cosines. I'm going to call this X, and let's go. So we're going to have the unknown side that's opposite the known angle squared equal to the other two sides squared, added together, 6 squared plus 7 squared, and then minus 2 times 6 times 7, and then times cosine, that's not an exponent, I'm just writing it because of the room, cosine of that opposite angle 120. There's the setup. Let's plug it into Desmos. Actually, first, before we do it in Desmos, we're going to solve for this by taking the square root of both sides. So we're taking the square root of this entire argument. Let's do that in Desmos now. So here you go. You plug in that entire argument into Desmos, and let me pull it out. You get 11.3 to the nearest tenth. So that missing side is 11.3. Boom, done. So for this one, we're trying to solve for this side opposite gamma. We'll just call it C. And now let's plug in the law of cosine. So it's that unknown side, C squared equals one of the other sides, 18 squared plus the other side squared, 23 squared minus 2 times those same sides, 18 and 23, and then times the cosine of the angle opposite the unknown side, which is 115. And then to solve for this, we have to take the square root of both sides to get just regular C. So let's plug this into Desmos now. And here we get 34.7 rounded to the nearest tenth. So C equals 34.7, boom, done. So for this one, we're trying to solve for A, but the problem is we don't have the right information to use law of cosines, at least not yet, right? I need to know this opposite angle to the unknown side. So the way we're going to do that is first we're going to use law of sines. We're going to go back to that because I can figure out what angle B is, or beta, and then I can use that to figure out the alpha angle. So I'm going to use law of sines. So I got sine of beta over the opposite side 10 is equal to sine of 113 over the opposite side 32. We're going to cross multiply. We got 10 sine of 113 equal to 32 sine of b. Then we're going to divide both sides by 32. And then to solve for angle B, we're going to take arc sine of this side right here. Actually, both sides, right? But it's going to cancel out the sign there. And so now we're going to plug this into Desmos and see what we get. And we get 16.72. So if we say this angle is approximately 16.72, that's 113. You add them together, you get 129.72. That means this one has to be 50.28 because these three together have to add up to 180. 50.28 plus this is 180. Now we can use law of cosines. So now we get a squared, which we don't know, is equal to one of the other sides squared plus the other side squared minus 2 times each of those sides, 2 times 10 times 32 times cosine of the angle opposite the unknown side, which is 50.28. And then, of course, to get a, not a squared, you have to take the square root, and let's do that in Desmos. And then we get rounded to the nearest tenth, 26.7. So a, or that missing side, is 26.7. Boom, done. For this one, once again, we can't use law of cosines right off the bat to get this missing side over here, which I'm going to call C. What we need is we need to figure out this angle first. The way I'm going to do that is I'm going to use law of sines, but I'm going to use law of sines to first figure out beta, and then we're going to use that to get gamma. So that would be sine of beta over its opposite side. And the reason why I can't go straight to this is because we don't know the opposite side. So I can't use law of sines for that, but I can here because I know that opposite side is 242.8 is equal to this other pair, sine of 43.1 over 184.2. Now we're going to cross multiply. So we get 184.2 times sine of b equal to 242.8 sine of 43.1. Not a lot of room here, but we're going to make it work. Then we divide both sides by 184.2. And then last step, we take arc sine of both sides, opposite of sine, right? Arc sine of both sides. And let's plug that into Desmos. And we get 64.24 degrees. And we can use these two now together to find gamma. If we add those together, we get 107.34. So that means this missing angle has to be 72.66, right? It's whatever basically adds to this to get us to 180. Now we can use law of cosines, right? Because now we know the angle opposite C. So we got C squared is equal to, then we have the other two sides. So first 184.2 squared plus the other side, 242.8 squared, minus 2 times each of those sides, times cosine of that opposite angle, which is 72.66. Then to solve for C, we take the square root of both sides. Let's plug that into Desmos. And we get 257.3. So C is 257.3. Now this was side-side angle, which means there is a chance that there could be two triangles, a second triangle. And we need to still test for that just in case there's another potential C value. So when we got 64.24 and we subtract that from 180, we end up with 115.76. And then if we take this and we add it back to the given angle, guess what? We got something less than 180. That means there is a second triangle. So then that means that in the second triangle, 115.76 would be the beta. Because remember, this is what we were solving for originally with the law of sines. So instead, this would be 115.76. And in this alternate triangle, this would no longer be 72.66, right? Instead, since 115.76 plus 43.1 is 158.86, in the second triangle, this would be 21.14. So that means it's literally the exact same formula. I just replaced 72.66 with 21.14 degrees. So we're going to swap this out in Desmos now. And we end up with 97.2. I know it's slightly different than what they got in the back of the book, but I'm pretty sure this is a tiny bit more accurate. But that's the general process. So we also get 97.2. So these are the two potential values for that missing side C. Boom, done. So for this one, we can't start out right off the bat with law of cosines because we don't know the angle opposite the unknown side. So we got to start with law of sines. And that's a great way to approach it, by the way. See, can I use law of cosines? If I can't, then go to law of sines. And we're going to use law of sines to find alpha first because we know the side opposite. So we got sine of alpha over 105 is equal to sine of the other pair, 50 over 45. Then we're going to cross multiply like so. We got 105 sine of 50 is equal to 45 sine of alpha. And then we're going to divide both sides by 45 like so. And then we have to get rid of the sine. So we have to do the opposite of sine, which is take arc sine. So we're going to take arc sine of this entire argument. And let's plug that into Desmos now. Now, when we plug it in, we get undefined. This is the situation when using law of sines where we get a no triangle situation. This triangle is impossible. So we say not possible for such a triangle. That's it, done. So for this one, we're trying to find angle C, and we'll just keep it as a variable as C. And we're going to use the law of cosines to do this, okay? And what the key thing is, if we're trying to find this angle, this is the side opposite. So this has got to be the side on the other side of the equal sign by itself. So it's 20 squared, right? Because the side and the angle have to kind of be on like opposite sides of the equation. So you'll see what I mean as I put it together. 20 squared equals the other side squared plus the other side squared minus 2 times these two sides, 13 and 14, and then times cosine of this opposite angle, which we don't know, but we're going to call it C. All right, now we can start to solve. So we got 20 squared is 400. That's 169, and that's 196. And then 2 times 13 times 14 is 364. Okay, Now we're going to add these together. We're just basically isolating and solving for c. So we're going to add these together, and that equals 365. Then we're going to subtract 365 from both sides. Let's go up here. We get 35 equals negative 364 cosine of c. Then we're going to divide by negative 364. So we get 35 over negative 364. And then last step, we have to get rid of the cosines. We have to take arc cosine of both sides. Let's plug that into Desmos now. And we get 95.5 degrees for the angle. So the answer is 95.5 degrees. Boom, done. So for this one, we're trying to find angle A. So using law of cosines, I'm going to say 13 squared because we're starting with the side that's opposite the unknown angle that we're trying to solve for. 13 squared equals the other two, 22 squared plus 28 squared minus 2 times those other sides, again, 22 and 28, and then times cosine of the angle we're trying to find. In this case, it's A, so we'll put A in here. Now we're going to solve. So first we got 13 squared is 169 equal to 22 squared, which is 484, plus 28 squared, which is 784, minus 2 times 22 times 28, which is 1232, and then times cosine of A. All right, now we're going to add these together, and we get 1268. Then we're going to subtract both sides by 1268, and we get negative 1099 equal to negative 1232 cosine of A. Then we're going to divide both sides by that. Of course, the negatives cancel out. And then last step, to solve for A, we're going to take arc cosine of both sides, which means we're taking arc cosine of this quantity, and that's going to equal A. Let's see it in Desmos. And we get 26.9 rounded to the nearest tenth. So A is 26.9 degrees. Done. So for this one, we're meant to solve the entire triangle, and we're going to start by solving for this side opposite the angle 35, and we're going to call that side little a. So let's set it up now. We got a squared, the unknown side, opposite the known angle is equal to then the other two sides, each squared, 8 squared plus 11 squared, and then it's minus 2 times 8 times 11, those same two sides, and then times cosine of that angle 35. So to solve for A, all we got to do is take the square root of both sides. So I'm just going to straight up plug this into Desmos as is. And we get 6.4 rounded to the nearest tenth. Now that we have this side, now we can solve for the missing angles using law of sines. Okay, so now we'll go to law of sines. We got sine of 35 over the opposite side, which is 6.4, is equal to, let's find angle B now. We got sine of B over 8, and now it's cross multiply. So 8 sine of 35 equals 6.4 sine of B. Divide both sides by 6.4. And then we got to get rid of that sine, so we got to take the opposite of sine, which is arc sine. So we're going to take arc sine of 8 sine of 35 over 6.4, like so, and that's going to equal B. And instead of doing 6.4, I just put in a few more digits just to be safe, just to get it more accurate. But we get 45.9 rounded to the nearest tenth for this angle. So B is 45.9 degrees. And the nice part about that is then we can find C just by using the triangle angle sum theorem. 35 plus 45.9 is 80.9, which means this has to be 99.1. That's C. So we got 99.1 degrees, 45.9, and then the missing side of 6.4. That's how you do it. Done. So for this one, we're going to start by solving for little c, which is opposite the known angle. So we're going to use law of cosines to do that. So we got the unknown side c squared, and we have to start with this side because it's opposite the known angle, equals the other side squared plus the other side squared minus 2 times each of those sides, 21 and 37, times cosine of the known angle 121. So now to solve for c, we have to take the square root of both sides, right? So let's plug that into Desmos as is. And we get 51.1 rounded to the nearest tenth. So c is 51.1. Now we have to find the missing angles. To do that, I'm going to use law of sines now that I have a known opposite side and angle combo. So I've got sine of 121 over its opposite side, which is 51.1, is equal to, let's find beta, sine of beta, and again, this or B, I should say, this is arbitrary. I could have found A because we also know that side, but sine of B over its opposite side, which is 37. Now we're going to cross multiply, and we get 51.1 sine of B is equal to 37 sine of 121. Then we're going to divide both sides by 51.1 to isolate, and then to get rid of the sine, we have to take arcsine of both sides. So let's plug this into Desmos now. And we get 38.4 rounded to the nearest tenth. So B is 38.4 degrees. And then to find this missing side, or angle, I should say, we just add these two together and use triangle angle sum theorem. So you add those together, you get 159.4, which means to add up to 180, this missing angle has to be 20.6 degrees. So my missing angles are 20.6 for A, 38.4 for B, and then the missing side is 51.1. That's how you do it. Done. So in this one, we know the three sides, but we don't know the missing angles. So we have to start with law of cosines. I'm arbitrarily going to solve for angle C. And again, we could solve for any angle we want first, but let's do that. And then the opposite side to that is 5. So we start with that opposite side, 5 squared equal to 3.1 squared, the other side, plus the other side, 3.5 squared, minus 2 times 3.1 times 3.5, right? Those same sides here and here. And then times cosine of the opposite angle to this, which is C. So now as we simplify, we got 25 is equal to 3.1 squared is 9.61, 3.5 squared is 12.25, and then 2 times 3.1 times 3.5 is 21.7, and then we got cosine of C. So I'm going to add these together. And we've got 21.86 minus 21.7 cosine of C. Then we're going to subtract this from both sides. And we got 3.14 equal to negative 21.7 cosine of C. Then we're going to divide both sides by negative 21.7. And then last but not least, we have to take arc cosine. We have to get rid of that cosine. So we have to do opposite of cosine, or arc cosine of 3.14 over negative 21.7. And that's going to give us our value for C. So let's see that in Desmos. And we get 98.3. I know in the back of the book they got 98.4, but I think this is actually the more accurate response. So C will be 98.3 degrees. Now that we have this, I'm going to use law of sines. And honestly, it's because I can, and it's because it's easier at this point. So that's what I always go to, path of least resistance. So now I can say sine of that 98.3 over 5 is equal to, let's solve for A, how about just randomly? I could have solved for B, but sine of A over its opposite side, which is 3.1. Now we're going to cross multiply, and we got 3.1 sine of 98.3 is equal to 5 sine of A. Then we're going to divide by 5 like so. And then we have to take arc sine of this side, right? Because that's how we get rid of the sine. So let's see that in Desmos. And here we get 37.8 to the nearest tenth. So if A is 37.8, that's 98.3. We can add those together to get 136.1, which means this final angle will have to be 43.9. So you see it's a little tiny bit different than what they got in the back of the book, but pretty much the same. So the angles are 43.9, 37.8, and 98.3 degrees. That's how you do it. Done. So here we're trying to find the area of a triangle with these side lengths, and we're using Heron's formula, right? When we have the 3 side lengths, no angles, this is what we got to do. So first we have to find S, which is basically the average of the perimeter. So I'm going to add these up, add 18, 21, and 32, and divide it by 2. So that's 71 divided by 2, which is 35.5. And then the formula is square root of S, or semi-perimeter, which is 35.5 times 35.5 minus the first side, and this is in no particular order, but minus that, which is 17.5 times 35.5 minus 21, which is 14.5, and then 35.5 minus 32, which is 3.5. So let's plug it into Desmos. And we get 177.56 to the nearest hundredth. And since this is in inches, it's 177.56 inches squared. That's how you do it. Done. So for this one, we're going to find the area using Heron's formula, which I've got up here. So first we have to calculate S, and we do that by adding these up and dividing by 2. So if we want to do it without a calculator, you can get a common denominator of 12. So that is 6/12. This is 4/12, and this is 3/12. And if you add them all up, 6 plus 4 plus 3 is 13/12. Half of 13/12 is 13/24, right? Because basically, it's like you take it and you multiply the denominator by 2. That's how you take half. So S is 13/24. Now we can use the formula. So it's the square root of 13/24 times. So then I just wrote these up with common denominators of 24. This is just so we can do it easily mentally without having to use a calculator. So then we do the difference of 13/24 minus 6/24, which is 7/24, and then times the difference of this and this, which would be 5/24. I'm not doing it in any particular order, right? And then we take the difference of this and this, which is 1/24. All right, let's plug it into Desmos. And to the nearest hundredth, this rounds up to 0.04. So the answer is 0.04. Again, it's area, so it's meters squared. And there's your answer, done. So this one we have to start by calculating S, and we do that by adding the three sides together and then dividing by 2. So this is 4.2 plus 4.1, which is 8.3, divided by 2, which is 4.15. So that's my S value. And now we can solve using the formula. So we got S, which is 4.15. And then times the difference of 4.15 and we're one of the sides, right? We're just gonna, there's no particular order. This could be A, B, and C. Let's just go with that. So 4.15 minus 4.1 is 0.05 times 4.15 minus 2.6, which is 1.55. And then times 4.15 minus 1.6 is 2.55. Let's plug that into Desmos. And we get 0.91 rounded to the nearest hundredth. So the answer is 0.91 yards squared. Boom, done. So for this one, we're trying to solve for x using the law of cosines, and it's great because we do know the angle opposite, so we're good to go. So we can say the side we're trying to find, x squared, is equal to the other side squared, 3.4 squared, plus the other one, and in no particular order, right? I could switch these, it doesn't matter. And then minus 2 times those same sides, 3.4 and 4.5, times cosine of the angle opposite this, which is 42 degrees, okay? And now we got something to solve for just by taking the square root of both sides. That will give us x. Let's plug it into Desmos. And we get 3.0 rounded to the nearest tenth. So x equals 3.0, boom, done. This one we're going to use law of cosines to solve for the missing side. And it's good to go because we have an opposite angle that we know. So we have x squared, the unknown side, equal to the other two sides squared, 23 squared plus 30 squared, minus 2 times those same sides, 23 times 30, and then times cosine of the angle opposite the unknown side, which is 65. All right, and then now to solve for this, we got to take the square root of both sides because I don't want x squared, I want x. So let's plug this quantity into Desmos, and we get 29.1 to the nearest tenth. So x equals 29.1, boom, done. So here we're going to use the law of cosines again because we have a missing side and a known angle, and they're opposite of each other. So we have the unknown side x squared equal to the other two sides squared and added together. So 1/5 squared plus 1/3 squared in no particular order, minus 2 times those same sides, 1/5 and 1/3, and then times cosine of the angle opposite the unknown side, which is 123. And now if we want to solve for this, all we have to do, because I want x, I don't want x squared, so I got to take the square root of both sides. And if I just plug this into Desmos, we're good to go. So let's do that now. So we get 0.5 rounded to the nearest tenth. So x equals 0.5, boom, done. So for this one, it's an angle that we're solving for, but it's the same thing. We're still going to use law of cosines, and I'm going to use this side first because we need to pair it with the angle that we're solving for, which is A, and it's opposite that side. So we're going to start with 125 squared equals the other sides squared and added together like this, minus 2 times those other sides, times cosine of the angle opposite this side, which is A, and that's what we're solving for. So now I got 125 squared, which is 15625, equal to 100 squared, which is 10,000, plus 115 squared, which is 13,225, minus 2 times 100 times 115, which is 23,000, and then we still got the cosine of A. So now let's add these together. We got 15,625 equal to 23,225. Then we're going to minus this from both sides. Then we get negative 7,600 equals negative 23,000 cosine of A. Divide both sides by negative 23,000 like so. And then we have one more step because that's gone, the negatives cancel out, but we need A, not cosine of A. So I have to get rid of the cosine by taking arc cosine of both sides. So it's arc cosine of this quantity is equal to A. Let's plug it into Desmos. And we get 70.7. And again, since we're solving for an angle, A equals 70.7 degrees. Boom, done. So for this one, we're going to again use law of cosines to solve for that a, and that means we need to start with the side opposite the unknown angle. So we got 40.6 squared equal to the other two squared in no particular order, 38.7 squared plus 23.3 squared minus 2 times these two all multiplied together, and then times cosine of the angle opposite this side, which is A. So now we got this value squared, which is 1648.36, equal to this value squared, which is 1497.69, plus this squared, which is 542.89 minus 1803.42 cosine of A. All right, now let's isolate A. So we add these two together and we get 2040.58. Then we have to subtract 2040.58 from both sides, and we get negative 392.22. Then we get a divide by negative 1803.42. And then the last step is we have to take arc cosine of both sides to get rid of that cosine. So we take arc cosine of this quantity, knowing that the negatives cancel out. So let's plug that into Desmos now. And we get 77.4 degrees to the nearest tenth, which means A equals 77.4 degrees. Boom, done. So for this one, we got to solve for this unknown side, and we're going to do so using the law of cosine. So again, the unknown side, since it's opposite the known angle, is going to be x squared, we're starting with that, equal the other two sides squared in no particular order, minus 2 times the one known side times the other known side times cosine of the angle opposite this, which is 60. Now to solve for x, we have to take the square root of both sides, and then let's plug that into Desmos. And we get 24.97, which would be 25 rounded to the nearest tenth. So x equals 25.0, boom, done. So for this one, we're trying to solve for this unknown side here, and I'm going to label it C, and we're going to use law of cosines to do that. So we're going to start with the unknown side because also it's opposite the known angle. So C squared equals, and then it's the other two sides, 13 squared plus 20 squared minus 2 times, again, those same sides, 13 and 20, and then times cosine of the angle opposite the side that goes here, which is, of course, 22. Now to solve, we're going to take the square root because I don't want C squared, I want C. So let's plug this into Desmos now. And we get 9.3 to the nearest tenth. So 9.3 is the missing side. Done. Here we're going to use Heron's formula to find the area of this triangle. So first we have to calculate S, and we do that by adding all of the sides together, 8 plus 12 plus 17, and we divide it by 2. So that's 37 divided by 2, which equals 18.5. So that's S. So now let's plug it into the formula. So you can see we get S, which is 18.5 times S minus A. We'll just call this A, B, and C. It's arbitrary, right? But we'll just go with that. So 18.5 minus 8 is 10.5 times A minus B. 18.5 minus 17 is 1.5. And then the S minus C, 18.5 minus 12 is 6.5. All right, let's plug it into Desmos. And to the nearest hundredth, we get 43.52. So the area is 43.52 to the nearest hundredth. Boom, done. So for this one, again, we got to use Heron's formula to find the area. So first we need to find S, which we can do by adding up all the known sides and dividing by 2. So on top, we get 8.8 divided by 2, which is 4.4. And then using the formula, we got the S value, 4.4, and then times the difference of S and each of the three sides. And we don't have to go in any particular order. Let's start with 4.3. So 4.4 minus 4.3 is 0.1. 4.4 minus 2.6 is 1.8. And 4.4 minus 1.9 is 2.5. All right, let's plug it into Desmos. And we get 1.41 to the nearest hundredth. So the answer is 1.41. Boom, done. So this one, again, we're going to use Heron's formula, and we're going to start by solving for S. And we do that by adding the three sides up and dividing by 2. Now, so I can keep it in nice fractions, we can kind of do this work mentally. I'm going to get common denominator. So I'm going to get everything over 30. So now what I'm going to do is I'm going to add these up, and then I'm going to divide by 2, which is the same as multiplying by 1/2. So here we get 35 plus 18, which is 53 over 30, but then we multiply by 1/2, which means we doubled the denominator, so now it's 53 over 60. So now using the formula, and again, getting these all with a common denominator of 60, we're going to plug it into the square root formula, and then we're going to eventually plug it into Desmos. And again, I'm putting up these common denominators not because I need to, it's only because I want to, so I can do this mentally a little bit more easily. So first we have the S, which is 53 over 60, and then it's s minus one of the sides. No particular order, but we're just going to do 1, 2, 3 like that, right? So 53 minus 36, that's 17 over 60. And then 53 minus 40, that's 13 over 60. And then 53 minus 30, that's 23 over 60. All right, let's plug it into Desmos. And we get 0.14 to the nearest hundredth. So our answer is 0.14. Boom, done. The sides of a parallelogram are 11 feet and 17 feet. The longer diagonal is 22 feet. Find the length of the shorter diagonal. So when they mean the longer diagonal, it's going to be from this corner to this corner. So they're saying this one is 22, and they want the shorter diagonal, which would be from here to here, and I'm going to put that in red. And we also know that the opposite sides are congruent, so I can also say this is 11 and this is 17. Now, that's pretty awesome because we now have a triangle, right? Where I know all three sides, 22, 17, and 11. So I can use the law of cosines now to solve for one of the angles in the triangle. And once I do that, then I can start to figure out the length of the red diagonal, the shorter diagonal. All right, so I'm gonna opt to solve for this angle right here, and we're gonna call that x. So in this highlighted red triangle, we're gonna use the law of cosines. And since we're trying to solve for x, I'm going to start with the side opposite x, which is 17. So we got 17 squared, which is equal to, and then we got the other two sides, which are 11 squared and then 22 squared, minus 2 times 11 times 22, right? Those same two sides, and then times cosine of that missing angle, which is x. Now we got 17 squared, which is 289, equal to 121 plus 484 minus 2 times 11 times 22. That's also 484. And then we got cosine of x. Okay, so now let's add these together. And we get 605. Subtract, as we're just trying to isolate, right? Typical algebra. And then we got negative 316 equals negative 484 cosine of x. And we're going to divide by negative 484. And we get cosine of x is equal to, the negatives are going to cancel out, 316 over 484. Last step to get rid of that cosine, we're going to take arc cosine of both sides, and let's plug it into Desmos. And we get 49.2399 degrees. So we'll just round up to 49.24. Now we're in a great spot because now we can start to figure out what this red length is. Now, the other thing to note is that in a parallelogram, the diagonals bisect each other. So if this whole thing is 22, this other little side here is 11. And this is pretty cool because now if I know that this angle is here, I've got two sides in this triangle and I don't know this side. So now I can use the law of cosines again in this little mini triangle to solve for this length here. And then once I get that, I just double it because again, the diagonals bisect each other. So this piece here is exactly half of the whole thing. So I hate to erase all that work, but we need the room. And what I'm going to do now is I'm going to call this side here y, okay? So we're solving for that side. So in law of cosines, I'll say y squared is equal to, and then cosine of this angle is going to go on the other side, on the opposite end. Y squared equals 11 squared, that's this side, and then plus the other side, which is this, for this little mini triangle here. It's 11 squared again, minus 2 times 11 times 11 times cosine of this angle, 49.24. Okay, now to solve for this, all I got to do is take the square root of both sides. So let's plug it into Desmos now. And we get 9.165. But again, remember, this is half of the diagonal that we want. So to get the final answer, we multiply this by 2, and we get 18.3 to the nearest tenth. So the answer is 18.3, boom, done. So this one says a regular octagon is inscribed in a circle with a radius of 8 inches. Find the perimeter of the octagon. So what I'm starting with is I just drew in a bunch of diagonals. And the reason why is it just gives us a nice precise location for the center. You don't need to draw in this much. But anyways, then it says this circle has a radius of 8 inches. So this is 8 inches here and this is 8 inches here. The other thing we can do is we can actually figure out this angle because if it's a regular octagon, I'm assuming, and it does say regular, so all the sides are equal, everything like that. It also means that all these angles are perfectly equal, which means since I have 8 of them, right, it's an octagon, I would just say what's 360, the total number of angles going all the way around a circle. What is that divided by 8? Quick mental trick to divide by 8, you take half, half, half. So half is 180, half of that is 90, half of that is 45. So I know the central angle here is 45. Guess what? I now have enough information to use law of cosines, at least to find one side length. And then whatever I get there, I can multiply it by 8 to get the full perimeter. Okay, so let's set it up. We got x squared, the unknown side, which is opposite the known angle, equals one of the sides squared plus the other side squared minus 2 times the product of those two known sides, and then times cosine of the angle opposite this, which is 45. Last, to solve for x, we got to take the square root of both sides. So we're going to plug that into Desmos now. And here we go. We get 6.12 for one side. But again, we need the full perimeter. So there's 8 sides. So if we multiply this whole thing by 8, so we get that nice perimeter of 48.98 to the nearest hundredth. So we got 48.98 for the win. Boom, done. So for this one, it's relating to this equation, and it wants to draw a triangle that represents that equation. Now, I'm not drawing it to scale because I'm just sort of putting in the values, but I'm not going to try and get it perfect. But the bottom line is this side is going to be opposite that angle. I know that from law of cosine. So I know that if this is x, the 52 degrees is going to go here. And then the other two sides in no particular order are going to be the square root of 25, which is 5, and the square root of 36, which is 6. That's how you put it together. Done. So for this one, we're trying to find the area of the triangle. But the thing is, to use Heron's formula, we need this side over here. So we're going to start with the law of sines. I'm going to start by trying to find this angle. So we got sine of 22 over its opposite side, 3.4, is equal to, let's call this angle A, sine of A over the opposite side, which is 5.3. And then we can cross multiply. We got 3.4 sine of A is equal to 5.3 times, 5.3 sine of 22. Now we're going to divide both sides by 3.4. And then after that, we have to take arc sine of this side to get rid of the sign there, right? To isolate. So we got A equals arc sine of 5.3 sine of 22 over 3.4. Let's plug that into Desmos now. And we get 35.7 for the angle. So A is 35.7 degrees. And then we can also find this one up here using the triangle angle sum theorem. 22 plus 35 is 57.7, which means this remaining side has to be 122.3. Now, by the way, I can use law of cosines now to solve for this missing side. So now let's make some room, and we're going to use law of cosines to solve for that missing side. So we're going to call this x, and then it's going to be x squared is equal to the other side squared plus the other side that's given squared minus 2 times both of those, and then times cosine of the angle opposite this side, which is 122.3. And to solve for x, we need to take the square root of both sides. So let's plug that into Desmos now. And we get 7.675 for that other side. Now we have enough to use Heron's formula. So we can use it as follows. First, we have to find what s is. So we have to add the 3 sides together and then divide by 2. And we get 8.1875. So that's our s value. Now let's use the formula down here. So we got square root of that s value. And then we take this and the difference of each of these 3 sides. So first, 8.1875 minus 7.675 is 0.5125. 8.1875 minus 5.3 is 2.8875. And last but not least, this minus 3.4 is 4.7875. All right, let's plug it into Desmos. And we get 7.616, rounded to the nearest tenth, of course, or hundredth, of course, is 7.62. So we have an area of 7.62, boom, done. So for this one, I'm going to actually start off with the law of sines to find these inside angles, and then we're going to use that to find the missing side here, which we'll call this x. So the first angle I'm going to solve for, let's call it A. We're going to put it in here, and we're going to set up the law of sines as follows. So we got sine of A over the opposite side, 18.8 equals sine of 18 over its opposite side, which is 12.8, and then we're going to cross multiply. We got 12.8 sine A equals 18.8 sine of 18. And then we're going to divide both sides by 12.8. And then we're going to take arc sine of this side to get rid of the sign here. That's just to isolate. So A equals arc sine of this entire quantity. So let's plug this into Desmos now. And we get 26.99. Let's round that up to a nice 27 degrees. So if this is 27 degrees, that's 18. They add together, they get 45. So this has to be 135 degrees. Now we can use the law of cosines to solve for x. So let's do that now. So we got x squared is equal to the other two sides squared, 12.8 squared plus 18.8 squared minus 2 times 12.8 times 18.8, right? Just the regular formula. And then times cosine of the angle opposite the x, which is over here, which is 135, all right? And then to solve for this, we don't want x squared, we want x, so we take the square root of both sides, so let's plug that into Desmos now. And we get 29.28 for that other side. And now we have all three sides, now we can use Heron's formula, so let's do that now. So taking those three sides, we can first calculate the s value by adding them up and then dividing by 2. And that gives us 30.44. So that's my s value. Now let's plug it into the formula and let's see what we get. So we got 30.44, and then we multiply it times the difference of s and each of the individual side lengths. So for example, 30.44 minus 29.28, that's 1.16. 30.44 minus 18.8 is 11.64. And last but not least, this minus 12.8, that is 17.64. All right, let's plug it into Desmos. And when you plug it all in, we get 85.1 to the nearest tenth. So the area is 85.1, boom, done. A satellite calculates the distances and angles shown. Find the distance between the two cities. So I'm going to draw on a little line here, and we're going to complete the triangle, and this is the distance between the two cities. So now you can see that this is set up perfectly for law of cosines, and I'm going to call this side in red, I'm going to call it x, so let's set it up now. So we got the unknown side x squared equals one of the known sides squared plus the other one squared in no particular order minus 2 times the product of these guys, and then times cosine of the angle opposite this, which is 2.1 degrees. And then since we're not trying to find x squared, we're trying to find x, we got to take the square root of both sides. Let's plug that into Desmos now. And we get 23.95 rounded up would be 24.0. So the answer is 24.0 kilometers is the distance between the two cities. Done. A 113-foot tower is located on a hill that is inclined at 34 degrees. A guy wire is to be attached to the top of the tower and anchored at a point 98 feet uphill from the base of the tower. So this is the guy wire right here. It says find the length of the wire needed. So we're just going to highlight that in red, and now let's take a look. So we know we got 98 here, we got 113 here. And in this triangle, in order to use the law of cosines, I need to know this angle. So let's see if we can figure that out. I see that this is 34 degrees. And so if I connect the line straight down, I can start to kind of piece together that angle. So for example, if this is 34 and this is a perfect right triangle, then this angle up here has to be 56 because these two need to be complementary, right? Because in a right triangle, those are complementary, so all three add up to 180. So if this is 56 and this whole thing is 180, this over here is 124, right? 124 plus 56, that's 180. And then this adds up to 180, which means over here, this is again 56. The other way to look at that is these two are vertical angles from geometry. Okay, now we have enough information to solve for x. So let's do that using the law of cosines. So we got x squared equals, and again, we use the x on this side because it's opposite the known angle, equals the other known side squared plus the other known side squared in no particular order, minus 2 times 113 times 98, and then times cosine, again, of the angle opposite this side here, which is 56. Last but not least, we want x, not x squared, so we have to take the square root of both sides, and let's plug it into Desmos. And here, rounded to the nearest tenth is 99.9. So the length of the guy wire is 99.9 feet. Boom, done. The graph in figure 17 represents two boats departing at the same time from the same dock. The first boat is traveling at 18 miles per hour at a heading of 327 degrees, and the second is traveling at 4 miles per hour heading at a heading of 60 degrees. Find the distance between the two boats after 2 hours. So again, we kind of got a nice little depiction here, and the distance would be this line in red. So you see now we have a nice triangle. Now, the question is, right, how far have they gone in 2 hours? If this one's going 4 miles per hour, in 2 hours, it's gone 8 miles. And for this one in 2 hours, it's gone 36 miles. So now we have the side lengths of the triangle. The thing that we're missing is this angle. So when they say a heading of 60 degrees, what they're saying is from this point here, just kind of like the unit circle, we're going up 60 degrees, which means this angle in here between the x-axis and this vector would be 60 degrees. And then this angle we have to calculate because it's going 327 all the way around, right? Which means the remaining chunk is 360 minus 327, which is 33. So there we have 60 and 33, which combine to give us that nice angle of 93. Okay, now we have enough information. Now we can set it up. So using the law of cosines, where the unknown side is x, we have x squared equal to, again, 8 squared plus 36 squared minus 2 times 8 times 36 times cosine of this angle because it's opposite that. And then we want to take the square root because we don't want x squared, we want x, so let's plug that into Desmos now. And rounded to the nearest tenth, we get 37.3. So the answer is 37.3 miles. That's how you do it. Done. A pilot flies in a straight path for 1 hour and 30 minutes. She then makes a course correction heading 10 degrees to the right of her original course, and then flies 2 hours in the new direction. If she maintains a constant speed of 680 miles per hour, how far is she from her starting position? So here's her starting point, and we're first going this straight distance at 680 miles per hour in an hour and a half. So to figure out what that distance is, I multiply 1.5 times 680, which gives us a distance of 1,020 miles. Then there's a course correction of 10 degrees. So going 10 degrees to the right, let's just say right is like kind of going down. Let's just say like this. So that means if I kind of extended this out, this would be the 10 degrees. And then this distance, we're going again 680 miles per hour for 2 hours, 2 times 680, that's 1,360. And then now we want to know how far are we from the starting position, meaning what is this red value here, this red length? And before we can run the law of cosines, I need to know the angle opposite that unknown side. So if this is 10 degrees and this full thing would be 180, this would be a nice 170 degrees. Okay, now let's set it up. So we're going to call this side x. So we get x squared equal to 1,020 squared plus 1,360 squared minus 2 times both of those, 1,020 and 1,360, times cosine of the angle opposite this, which is 170. Then we want x, not x squared, so I got to take the square root of everything, and we're going to do that in Desmos. And we get 2,371 rounded to the nearest whole number, so it's a distance of 2,371 miles. Boom, done. Philadelphia is 140 miles from Washington. Washington is 442 miles from Boston, and Boston is 315 miles from Philly. Draw a triangle connecting these three cities and then find the angles. So this is not meant to be to scale. I just kind of drew a random triangle, but now we're going to mark it with the values. So 140 between Philly and Washington. We got Washington and Boston is 442. And then between Boston and Philly is 315. Now we need to find the angles. So we're going to start with law of cosines. And I'm going to arbitrarily start with this angle here. So we got to start with the side opposite. 140 squared equals the other two sides squared. 315 squared plus 442 squared minus 2 times 315 times 442. And then times cosine of the angle opposite this, which is just b, and there we go. Now let's evaluate. 140 squared is 19,600. 315 squared is 99,225 plus 442 squared, which is 195,364 minus 2 times 315 times 442, which is 278,460. Big numbers here, and then times cosine of b. Now we're going to add these together, and we get 294,589. Now we're going to subtract by this amount on both sides. Again, we're just trying to isolate b here. And then we got negative 274,989 equal to negative 278,460 cosine of b. Then we're going to divide both sides by this constant, negative 278,460. These are going to cancel out, negatives cancel out. And then to do the final solving for angle b, I'm going to take arc cosine of this quantity because we have to isolate the b. That's how we get rid of the cosine. So arc cosine. And now let's plug this into Desmos. Rounded to the nearest tenth, we get 9.1 degrees. So b is 9.1 degrees. So now that we got 9.1, I'm going to use law of cosines again to solve for angle w. So we got 315 squared equals 442 squared plus 140 squared minus 2 times 140 times 442, and then times cosine of the angle that's opposite this, which is w. Okay, now we're going to solve. And then once you square everything and multiply this out, these are the numbers that you get. So then let's add these together. And then we get 214,964. Then we're going to subtract both sides by 214,964. And then we get negative 115,739 equals negative 123,760 cosine of W. Then we're going to divide both sides by negative 123,760 like so. And the last step, okay, by the way, the negatives are going to cancel out. The last step is we got to isolate W, meaning we got to get rid of the cosine, meaning I have to take arc cosine of this. So let's do that now in Desmos. And we get 20.7 degrees to the nearest tenth. So here we have 20.7 degrees. And to get the final angle, we can use the triangle angle sum theorem, which means that all three angles have to add up to 180. So since these two together add up to 29.8, the remaining angle must be 150.2 because they all add up to 180. So these are the three angles done. Two airplanes take off in different directions. One travels 300 miles per hour due west, and the other travels 25 degrees north of west at 420 miles per hour. After 90 minutes, aka 1.5 hours, how far apart are they, assuming they are flying at the same altitude? Okay, so let's draw this out. So first of all, we got traveling due west, so I'm going to make that going left. And 300 miles per hour in an hour and a half, that's a distance of 450 miles. And then this one says 25 degrees north of west. So here would be west, 25 degrees north might be like this, where this little angle in here is 25 degrees. And then this is at 420 miles for an hour would be 420 miles, right? 420 miles per hour. So an hour and a half would be 630 miles. And now we're trying to find the distance between them, aka this length, which we'll call x. And guess what? We got everything we need for law of cosine, so let's set it up. We got x squared equals 630 squared plus 450 squared minus 2 times those known sides, 630 and 450, and then times the cosine of the angle opposite this side right here, which is 25. And then we need x, not x squared, so I got to take the square root. Let's do that in Desmos. And we get 292.4 to the nearest tenth, so they are 292.4 miles apart. Boom, done. The four sequential sides of a quadrilateral have lengths 4.5, 7.9, 9.4, and 12.9. The angle between the two small sides is 117. What is the area? So let's draw it out now. So I'm trying to draw this somewhat to scale. So we'll say this is the 4.5, this is the 7.9, maybe this is the 9.4, and then this can be the 12.9. So it's not perfect, but it looks reasonably to scale. Okay, and then it says the angle between the two small sides, which are these two sides, is 117 degrees, so that goes in here. Now, if I draw a line across like this is actually pretty cool because I can now make two triangles, and then I can use Heron's formula to calculate the area of these two separate triangles. So first, I need to know what this side length is. And to figure that out, I'm going to use the law of cosines, and we'll call this x. So I can say for this triangle up here, we can say x squared equals 4.5 squared plus 7.9 squared minus 2 times both of those, 4.5 and 7.9, and then times cosine of the angle opposite x, right? Which would be 117. And then I don't want x squared, I want x, so I need to take the square root. So let's do that in Desmos. And then we get 10.72. So x is equal to 10.72. All right, this is amazing because now I have two triangles where I know all three sides, so now I can use Heron's formula. Okay, let's look at the first triangle. I'll put it in red, so we're going to do this one first. So first we need to calculate what S is, so we got to add these three sides and divide by 2. And then when we do that, we get 11.56. So that's my S value for the red triangle. So now let's plug in the formula. So we're going to take the square root. I don't have a ton of room, so I'm going to try and be economical as possible. So I got 11.56, and then we do times the difference of S and each of the three sides. So 11.6 minus 10.72 is 0.84, and then minus 4.5 is 7.06, and then minus 7.9 is 3.66. So let's plug it into Desmos. And then we get approximately 15.84. And this is the area for the red triangle. Now let's look at this blue triangle. So again, we need to start by calculating S. So I need to add this, this, and this and divide by 2. And we get 16.51. So that's our S value for the blue triangle. Now let's plug it into Heron's formula. So I just moved the infographic to make a little room. But bottom line is we need the square root of our S value, which is 16.51. and then times the difference of s and each of these three sides. So 16.51 minus 10.72 is 5.79. And then when we subtract 12.9, we get 3.61. And then when we subtract 9.4, we get 7.11. And then let's plug it into Desmos. And we get 49.53. And that's the area of the blue triangle. So to get the total area, we got to add these two together. And we get 65.37 rounded to the nearest tenth would be 65.4. And the units are centimeters. So since this is area, it's centimeters squared. That's how you do it. Done. Find the area of a triangular piece of land that measures 30 feet, 42 feet, and then an included angle measure of 132, round to the nearest whole square foot. So we've got 30, we've got 42, and then an included angle measure of 132. So obviously this is not to scale, but it's all good. Now, we can solve for this other side using law of cosines and then eventually use Heron's formula. But I'm actually going to go back and use a much easier formula from the last section because we have everything we need, which is the 1/2, and then we do the two sides multiplying each other, the known sides, right? 30 and 42. And this only works when we have an included angle, and we do have an included angle here. So then it's times sine of that included angle. So let's plug it into Desmos now. And we get 468 to the nearest whole number. So the answer is 468, and this is in feet, so square feet. That's how you do it. Done. I hope you guys enjoyed this video, and if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.